Hello everyone. Welcome to the first of 3 Tech Talks by Open Compute Project Foundation. It's great to see so many of you logged in today, and I can see more rolling in, so welcome. Now more than ever before, we're realizing the vast importance of data centers and cloud technology, which is fueled by hardware like OCP's vanity-free open source solutions. We hope this tech talk will be an opportunity for us all to come together at this difficult time and explore ideas that will shape our future. And importantly, we'd like to hear from you. So we'll open up the room to questions to our speakers near the end of the webinar. So please keep posting your questions in the chat box and we'll put them to our speakers later. Before I introduce our speakers, my name's Stuart. I'm the editor at W Media. We've partnered with OCP to bring you these digital events. I'm personally really excited because this is actually my first of these events with W Media, so I hope you enjoy it too. If you're interested in how you can connect with us and your business with our network, we'd love to have a chat about enhancing your digital marketing plans. So without further ado, here's our speakers. Joining us today, we have OCP's VP of Channels, Steve Helvie. Steve's extensive career in cloud services brought him to OCP, where he educates organizations on the benefits of open hardware design and community-driven engineering in data centers. Before OCP, he spent 14 years working across Asia, executing strategy for Microsoft and Rackspace. Joining Steve, we have Dharmesh Yani from Facebook, who leads the technical steering committee for OCP. The committee plays a pivotal role in all OCP's projects worldwide. Dharmesh has been a member of OCP since 2012, which was 1 year after Facebook launched OCP to bring innovation and collaboration to the hardware space. He also has more than 20 years of strategic experience in engineering development and project management. So we really do have some experience with us today. Today, we'll share with you a quick peek into how OCP is reinventing efficient data centers by comparing their models against traditional models. After that, we'll jump into a Q&A with Sachin Thakur and Ryosuke Ishihama from CTC in Japan. Sachin has been part of CTC for 10 years and has a strong experience in system administration and project management. Ryo has been with CTC for 15 years with experience in system engineering. Both Sachin and Ryosuke have worked with OCP for over 6 years and have worked across Southeast Asia to understand various OCP solutions. So after that Q&A, we'll explore a real-life example of how OCP has achieved energy and cost efficiencies using open source hardware for telcos and CPSs. And then finally, we'll deliver your questions to our speakers, so do remember to pop those in the chat section. There'll be a recorded session of this webinar, so we'll send you all the details later. So I'll let our speakers jump in now, and I hope you enjoy the session. Thank you so much.
Thank you, Stuart, and thank you to everyone for taking time out of your day. The last few months have been quite interesting, and I'm sure everyone's daily routine is quite different. So we hope that you find value in today's discussion as we share a few new ways that people are doing hardware infrastructure. And anytime you talk about the new way of doing things and replacing older methods, it's a good example of something called creative destruction. And I think we can all come up with famous examples of creative destruction, such as Spotify and the way that it creatively allowed us to consume music while destroying other aspects of, say, the MP3 player. You have Tesla, you have in Singapore, you have Grab, Food Panda. These are all really famous examples of big changes in technology. But economists have been studying creative destruction, and what they found is that it's not these big leap changes that create the most value in a market, but it's rather the small incremental changes that take place in a market or an industry that create the biggest value for consumers. So I want you to keep that in mind as I'm going to be sharing some examples of incremental changes throughout hardware and infrastructure. And also, when I talk about specific companies, keep in mind that these companies did not stop what they're doing one day and turn around and then do something different, an entirely new model the next day. They took time for incremental improvements along the way. So let's get started. Now, I know there's some people on the line that may or may not be aware of a couple different terms here, so I want to quickly define them. One is an OEM, and the other one is the ODM, or white box model. Now, these are primarily the two ways that somebody would go buy servers, storage, or networking devices. And there's a couple differences. One is on the OEM side. This company would then buy platform components from a manufacturer. They would bundle them or make a product out of it and then resell it under their brand name. And this is all of the big name brands of hardware providers that you see in the market. Whereas an ODM, or a white box manufacturer, would manufacture the components and then provide everything from design all the way up through production and development. The OEM tries to create products that serve the broadest possible market, whereas, say, an ODM may be a bit more specialized. And on the support side, it varies, whereas an OEM may be doing product support, but also some managed services and some software support. An ODM may do those type of services for specialized clients, but for other clients, they may just do basic product support. So I'm going to be referring to these two models a little bit throughout today's session. So when you take this ODM white box model and you add an open source community and an open source framework around it, that is really the basis and the genesis of the Open Compute project. The traditional way that technology always came to market is you had technology happening from all of these different tech companies, and then the OEMs would then take that technology, filter out what makes the most sense for them based on business reasons, and then pass that to the end user. And it created a bit of a bottleneck. But when we look at, say, the creative destruction and what Open Compute has been doing, is now you have a community-based engineering where you have end users, vendors and suppliers all working together under one group and one set of programmatic environments that allow you to exchange information, create common specifications and designs, and create that pace of engineering that's so valuable. So how did all this start around the Open Compute side? Well, this is back from January 2010 when Facebook decided that it was going to build its own data centers. And as they were building these data centers, they started to ask themselves some questions about what can we get rid of in a system? Can we raise the operating temperatures? Can we increase the humidity? And do we really need some of this stuff in the data center facility that we've had in the past? So as they worked through these problems with certain vendors and suppliers, they decided to take it one step further and open source all of those efforts. So with Facebook, Microsoft, Goldman Sachs, Rackspace, and Intel, they created the Open Compute project, where now we have over 200 companies with almost 190 contributions and 6,000 engineers. These 6,000 engineers working across a variety of projects, everything from networking to open systems firmware to rack and power, server storage, and even the edge. These projects are led by our volunteers, and they're overseen by the incubation committee. And we're pretty lucky today to have Dharmesh Jani, DJ, who is the chair of the OCP incubation committee. So DJ, thanks again for taking time to join us today.
Absolutely, Steve, happy to be here.
Great, DJ, you're across all of the different aspects of Open Compute, and you see all the projects working together. So as you see all of the efforts happening within the projects, and you look at the next decade of growth, what are some of the areas that you see happening the most when it comes to innovation across OCP?
Absolutely, Steve. That's actually a great question, and that's something we think about at all times. The lens with which we look at that is by looking at the set of problems which industry is going to face in next 10 years or so. And there are a couple of them which are right in front of all of us. First, what I call Cambrian explosion of workload is taking place right now with machine learning, AI, deep learning, pattern recognition, robotics, and all sorts of other applications which have emerged in just mere last 5 years. And that leads to new way of defining computer architecture. Bandwidth expansion is taking place. Previously, it used to be machine to human bandwidth, but now with all sorts of services coming online and ability to deliver disaster recovery at scale, machine to machine bandwidth is growing. And then last but not least, the problem which we all are facing is the tapering of the Moore's law. So with these three forcing functions, which I would call, there are some areas where OCP is really making a very big contribution to at least try to solve these problems. I will give three mentions. First, there is a new project called Open Domain Specific Architecture Project, which is under Server project. In this project, the goal is to look at chips which have been traditionally built as a system on chip and create a concept of chiplets where different set of chiplets could come together in different technology nodes, and you can design a system in package instead of system on chip. So anybody interested in this project, please go to the wiki of the OCP server and look under it, and you will find the ODSA project and all the details about it. The second initiative which I want to mention is all related to AI and machine learning. And this falls under OCP Accelerator Infrastructure Project, which is again a new project where the community is working really hard to solve all problems around AI machine learning, from training to inference, including building on new concepts called co-design, where you have to start looking at software and hardware in a holistic manner. And then the third mention, which is in the inception, I would say, is coming up with the entire software toolchain, which can be come to bear for solving problems such as booting of the systems, doing validation, test and validation, and even beyond going into deployment, provisioning, and fault management. And these are new areas which are going to become common problem areas for every user, and creating a common open software toolchain becomes vital for making this project go forward. So those are some of the areas which I feel we have a lot of energy above and beyond the traditional areas which are obviously moving at a very fast momentum.
Yeah, that's great, DJ. Those are some pretty interesting areas and very fast growing for our projects, I know. So as the chair of the IC incubation committee, what are some of the activities that you do across these projects, and are there any areas of specific focus other than the three that you mentioned on how the incubation committee looks at technology?
Absolutely. So incubation committee consists of a set of 11 individuals who are all part of Open Compute project. And there are expertise which range from networking to data center facilities to hardware management to storage, compute, firmware, telco. All sorts of expertise are represented among these 11 individuals. And as a charter, what we have done in the last 1 year is we have redefined some of the activities to include strategic directioning from the technology perspective. So identifying industry problems and critical areas for OCP community to focus on, and then finding ways to execute upon some of these identified directions by coming up with soft roadmaps for project teams to converge on. And last but not least, we also want to hold ourselves accountable. So we give periodic readout of the work and the direction which we have defined. And in fact, this discussion right now and this question is part of that exercise of sharing with the broader community here today on 4 areas which we have identified based on maximum interest of the community. So which are these 4 areas? The first is defining common platforms. The concept of common platform is to basically have operationally similar variants which can be deployed across multiple use cases, multiple customers. This makes design standard, and you don't want to have massive SKU proliferation. You want to consolidate everything into few standard designs which have maximum use. The second area which we have identified is the area of modularization. Disaggregation is a very big force which has been driving OCP since the very beginning, and modularization is again direction in that same step because of that force. There are a couple of projects which already embody principles. OCP NIC 3.0 and OCP Accelerator Module are 2 such examples of modularization. But we are looking at few others so that we can come up with a common form factor which can go into devices such as a compute server or a storage server and provide ability to give inference on the same form factor, perhaps video transcoding on the same form factor, perhaps new interfaces like CXL based memory devices on the same form factor. Again, the concept is, can we leverage common designs for maximal use? And then platform security is the third area, which basically includes designing security profiles for maximum set of devices which are part of OCP, because as we all know, security is extremely important in today's day and age. And then we have the fourth one, which is coming up with common profiles across all of these OCP hardware. So that includes plan to support devices which could be OCP inspired or OCP accepted products which are part of marketplace, and this could be through use of DMTF based standards or even open API based standards, and looking at things like adopting open BMC as a requirement for all of the devices, for instance, spanning compute and network and storage. So these are 4 areas I would like to highlight which have come out of work from incubation committee, and now we are looking at ways to engage with the community to move these 4 areas forward for greater benefit of everyone.
Yeah, that's good. DJ, you'd mentioned the words a common platform or common profile. So you mentioned that quite often. So when I think some people may be thinking, well, if everybody's making these common platforms and everybody's working together, then what's in it for the vendor community? Why do you think that why would vendors, what are the 2 or 3 factors of why a vendor would want to join OCP and work together with other vendors in the same sort of environment?
Absolutely. So when we talk about common, we talk about common more in terms of looking at technical terms. So I'll give you an example. Let's say you're building a car today. There are certain common concepts which are common for all sorts of cars from all different vendors. You won't be allowed to choose any type of lighting to have for your headlamps or for your turn signals. You have to comply with standards or common agreed upon design principles. With those in mind, there is still room for vendors to differentiate and vendors to come up with designs which could support their end customer. Common means ability to leverage things which can deliver products faster for everybody. So sometimes it is an advantage for vendor to adhere to the common standards, because you don't want to go and reinvent every last screw or every last design principle in data center infrastructure, because nobody is going to deploy that kind of a differentiated device at scale when there is only one of its kind available. You want to have ability to have redundancy, and you want to have ability to reduce your risk. This is not uncommon. This is quite common in almost every aspect of how people do their business. So being part of such a community actually gives you bigger opportunity. It gives you bigger benefits because you are differentiating where it matters, not at every point in the design, sometimes at the cost of it being not really relevant, but you're trying to differentiate.
Got it. Well, that's great, DJ. Thanks again for sharing those areas, and I really encourage the people attending today to take a look at our website and see all of the different projects that DJ is overseeing. And thanks again, DJ, for making the time.
Absolutely. Thank you, Steve, for having me here. This is exciting.
Great. So as DJ mentioned, that we are trying to do a lot around common areas. And there are really 4 tenets that drive everything within open compute: efficiency, scale, impact, and openness. And let me give you just a couple of examples of what I mean on this, specifically around, let's say, efficiency. This right here is a nice kaleidoscope of server bezels, the front panel that goes on the server. As you can see, all of these different kinds of servers, all these different brand names, what may be referred to in the industry as gratuitous differentiation. Being different for the sake of being different, but not really necessarily adding any value, and it can be quite frustrating for server technicians to deal with these type of individual parts. But let's take a look at an OCP Cubby server. Very minimalistic, vanity-free. It's a Cubby server that you simply slide into a chassis. It clips into a bus bar in the back of the rack with shared power across the rack. And let me highlight just a couple other things here on these server. These green touch points, as you can see the dials on these touch points, these are meant to enhance the simplicity of the OCP design. This is a toolless server. So all of the OCP servers that come through the foundation are toolless, meaning that if I'm a technician, I can simply use these green touch points to quickly unscrew or unlock a particular component and quickly replace that, any component within the server, without using tools. So this intense focus on simplicity drives everything we do within OCP. Let me give you another example. In a traditional server, you might have 8 40mm fans. In an OCP server, we have 2 80mm fans. The OU, or the unit height, is a bit larger. So the fan is a bit larger. That way we don't have to spin the fan as much to get the same amount of air. And one of my colleagues does a great job of explaining the fan cube law to me, which means that if you decrease the fan speed by 50%, you decrease the energy needed to spin that fan by 7/8. Let me repeat that again. I'm going to decrease the fan speed 50%. I'm going to then decrease the amount of energy needed to spin that fan by 7/8. All of this are great examples of incremental differences and changes around creative destruction. Here's another one around scale. So we had, as the edge continues to proliferate among all of the hardware vendors and all of the end users, there was a group within Open Compute, end users and vendors and suppliers got together within the Open Edge group and defined an Open Edge server footprint. They created a specification, and within just 2 or 3 months after that specification was published, we had multiple suppliers lined up to make that exact same server. So if I'm an end customer, I have a great deal of confidence knowing that now I can go at scale, I can use a common specification, and I can go have a multiple sourcing strategy across multiple vendors that mitigates my risk, and I can start to build out this scalable infrastructure that I need. So again, really good examples of incremental improvements and speed to market. And this has a wide scope when it comes to the edge. The definition's changing all the time, but people are going to be looking and consuming this type of product in various forms. A great article here around Walmart and the way that they're thinking about taking on Amazon. You know, Walmart has a lot of real estate, they have a lot of buildings, and 80% of Americans live within a 10-kilometer radius of a Walmart. So they're set up to be really attractive, interesting edge computing data centers or micro data centers. So as you can see, the speed to market within open compute and how it may affect industries, say, beyond a traditional edge application. So how does this translate into the numbers? Here are the server shipments and market share for Q4 of 2019. I'm going to pull out just a couple of these numbers that I want to mention. The bottom one, as you can see, the ODM direct. That is where the ODMs are selling direct to the end customer. Most of these ODMs are OCP members. There are names that you may not have heard about. WeWin, MyTech, EdgeCore. These are all large ODMs supplying OCP equipment to the market. I've also highlighted Inspur here at number 3. Inspur is a very, very active member within Open Compute, contributing many server designs. These growth and market share numbers have been pretty consistent over the last 5 to 8 quarters. We'll see how that changes here in the coming months, but I think that we'll see a dramatic change in these numbers across the board. But some people might say, well, that's great, just probably larger companies are buying more, but that's not necessarily the case. There is an analyst firm that tracks the OCP revenue, and that growth pattern is affecting, or is in correlation even in the non-large company hyperscaler market. So people in the enterprise segment are starting to consume more and more of this type of equipment, and you'll see the growth across APAC, Americas, and EMEA. A lot of that APAC growth is going to be coming out of North Asia, but we're seeing increased demand and interest coming out of Southeast Asia. So who's buying it? There are a few interesting verticals that we're seeing take up Open Compute. Of course, cloud service providers, but we're also seeing telcos use a great deal of open networking and open compute and storage resources at the central office or the edge as they move to 5G. We're seeing early stages in healthcare, automobile and manufacturing, fintech as well, really aggressive adopters of open networking within this segment. So why are people buying? There's really 4 areas: cost reduction, energy efficiency, standardization, and reliability. Cost reduction, it does depend on certain variables, how the cost plays out. We've seen some customers per unit cost go down very quickly. Some it may take 2 or 3 years of deployment to start to see that TCO come in line with expectations. But I do want to highlight a couple areas around energy efficiency. I mentioned a bit about the server design earlier. Well, SK Telecom out of Korea tested 3 different types of OCP racks against traditional legacy hardware. And they have an entire study here on this particular link below. But I pulled out the efficiency at 0 workload and at 100% workload. And you can see the difference in OCP efficiency at 0 and at 100. And what's important about the 0% workload number is that most of the servers sitting around the world sit at idle for a great deal of their time. And this is a big deal for some of these companies looking for ways to cut cost. But it's not just at the server efficiency side, it's also at the OpEx side. I mentioned the green touch points before. Well, Yahoo has done a great job of analyzing how does OCP compare operationally to traditional hardware. And they've measured this across every aspect of the server and the rack and the maintenance. And as you can see, 40% less time on average. They've been able to reallocate staff. They like the toolless design, and you can see the time differences here. So we're seeing OpEx is really one of the key areas where I'm seeing a great deal of feedback from end customers about how easy Open Compute is to manage. So those were two examples around APAC. Here's what's happening around the rest of the world, just a few examples. ING Bank Poland, seeing reduction in OpEx, as well as energy efficiency gains. The London Internet Exchange, it's the first internet exchange in the world to adopt an open networking model. PayPal, using open networking. This is Cumulus software on OCP switches. And RTB House, which is a very large marketing media company rolling out OCP for compute. Again, several examples, but I just wanted to share a few across the industries that I'd mentioned before. So how do I buy open compute equipment if I'm interested? So back to this traditional model. In the past, if I'm an ODM, I might sell the components to a brand name OEM vendor. They would then take those, make them into products and move them to traditional customers. If I'm a specialized customer, such as a cloud service provider, I might be able to sell direct. That's the old model. The new way, the incrementally new, better way, is in this open source model. If I'm an ODM, I can do that. If I have a large enough team and I want to do open compute myself, I can go directly to the ODM and purchase OCP gear. But many customers do not have a large enough team to manage their infrastructure themselves. In that case, you can rely on an OCP solution provider. And this is a group of companies within the community that provide a great deal of services around OCP solutions. Everything from rack integrations, delivery, installations, those managed services that a lot of customers really appreciate. So those that need help can rely on a solution provider, and those that may have a big enough team can go direct. But what we are seeing is that the mix of customers, it's not broken down into specialized or traditional anymore. All of these customers across all of these verticals are wanting the same best practices, the same efficiencies, the same common platforms that DJ mentioned in their environments. So I thought it would be helpful to hear from an actual solution provider. And it's not just any solution provider, but it's one of our top solution providers that we've had in the community for many years. They've done the most deployments in Asia. Sachin and Ishihama-san are based in Tokyo, but CTC has offices all around Asia. And I just wanted to ask them a few questions and get their thoughts on what it's like to be an OCP solution provider and what they're seeing in the market. So Sachin and Ishihama-san, thank you very much for taking the time to join us.
Thank you, Steve.
Thank you, Steve.
So why don't we take just a couple minutes? Please tell everybody a little bit about CTC and the types of OCP customers that you service.
Okay, so I will answer it. So actually, CTC is a Japanese value-add reseller and a system integrator. And we have been a OCP solution provider since 2014 as well. And our customers are mainly from CSP like OTT, Yahoo Japan, and ISP vendors. And we actually started building the momentum with OCP with these customers. And right now we are seeing a lot of interest from telecommunication sector also. So our next delivery is for telecommunication sector. Yeah. Ishihama-san, anything you want to add?
Yes. In addition, CTC has some footprints in APAC, such as Singapore, Malaysia, Thailand, and Indonesia, and the United States as well.
That's great. Yeah, I know that you guys are quite strong in Southeast Asia. So why did CTC start working with Open Compute? I mean, you're a very large integrator, you have many brands, so why take on this open hardware model?
Yes, as I just mentioned, we are a solution provider of OCP, and we are also value-add reseller. So that means that we do not manufacture OCP gears. We are not an entity for specific products, you know. So we actually have reseller agreement with HP, Dell, IBM, all these OEM vendors, and we also have partnership with various ODM vendors from Taiwan and China. So we resell their products, both OEM and ODM vendors. So OCP is mainly with Taiwan vendors. And CTC has been contributing for open source software community like OpenStack for quite a long. So we believe that open source momentum for hardware would soon come in near future like open source software. Based on this belief, we decided to contribute for the Open Compute project community, and we became the first OCP solution provider in Japan region in beginning from 2014. Yeah.
That's great. So what are some of the obstacles when you speak with customers that they're raising around this particular model? What are some of the barriers or concerns that customers have around working with OCP? And then on the other side, what are the key benefits that your current customers are seeing out of OCP?
Yeah, so compared to the traditional hardware, support level for OCP hardware is different since users need to manage hardware lifecycle by themselves. On the other hand, users can benefit of savings TCO, which includes procurement cost as CapEx, labor cost, and power cost as OpEx. So these are the main benefits that they see. I myself have been working with HP, IBM hardware, which are traditional hardware, and after operating those hardware, when I moved on to OCP, it's very simple. We can deploy several racks within few hours, so it's totally different. So these are the main benefits that most of our customers have seen with OCP, not just on the operations side. So the total cost of ownership for OCP, they were able to reduce it drastically compared to traditional hardware.
Good. Ishihama-san, do you have anything to add to that?
Yes. So in terms of the support services, CTC, especially in Singapore, has a capability to provide support service for users based on the request.
Great. Great. So, and if you're a customer thinking about starting this model, how big of a team would I need? And then how would you recommend customers start with Open Compute?
Yes, this actually depends on customer to customer, but I myself as a project manager, I have been managing several OCP based projects. So by looking at various customers, the minimum team members that you require is 4 people, which consist of 1 project lead, 1 network specialist, and 1 infrastructure engineer, and 1 DC operational manager. So these 4 members are the must, and they can manage hardware with less field engineers compared to traditional hardware, because as I just mentioned, like maintenance procedure for OCP gears is very simple. You don't need any screwdriver to operate it. No power cords need for any replacements, and everything is cold idle maintenance. So it's very easy to maintain.
It's great. So Ishihama, any last words?
Oh yeah, that's good. So I just want to double mention that. So it's very simple for the maintenance, and you can just try it.
Great. So thank you, Sachin. Thank you, Ishihama-san, for joining and sharing a couple ideas on what it's like to be an OCP solution provider and some of the feedback from customers. So thank you very much.
Thank you, Steve.
Thank you, Steve.
Yep. So I recommend that anybody that's interested, reach out to these guys. They're great. They have the deepest technical team across Southeast Asia and APAC in general. So if you're interested, taking a look at the particular products we have, go to the website. We have a marketplace around products, integrated solutions, circular economy. You'll see components there, basic switches, servers, storage nodes, but you'll also see integrated solutions. And people like CTC are taking the OCP hardware and they're wrapping enterprise cloud-enabled workloads around them and delivering them at scale to enterprise customers. So for example, this is a CTC solution here. It's running edge core switches, some WeWin or MyTech compute and storage nodes, all wrapped with Hadoop, Kubernetes, Red Hat, OpenStack, Docker, validated and supported by CTC. And of course, we have ODMs that are also producing these rack level solutions. This here is from an ODM Inspur, and it is a certified SAP HANA solution run Windows, VMware, Citrix, all on OCP recognized hardware. So we understand that people care a lot about the workloads. They want to know what actually runs on the hardware and can it be validated and supported. And so you'll see those solutions there. And lastly, if you really want to just get going, we have even starter kits that certain companies provide, which are desk side development kits that you can roll right under, plug right into your desk, and have your software developers start working right away. A couple resources here. We have OCP deployments or POCs in almost every country in Southeast Asia. So we have things happening in Cambodia, we have things happening in Indonesia, starting to happen in Vietnam, South Asia and India, of course, North Asia. So we're seeing this momentum, these incremental changes that are happening across countries. And right here is a list of resources. We have CTC, of course, in Singapore. We also have Open Computing Singapore. Wilson runs that particular company and works very closely with the companies in the middle here, which are MyTech, WeWin, EdgeCore, Cumulus, Inspur, etc. So a couple other announcements that you may be interested in. May 12th through the 15th, we are having our global summit, which was scheduled to be an in-person event back in March. That was canceled. We've moved it to a 3-day virtual event where we're going to have over 200 presentations across the 3 days, some of them extremely detailed and technical around advanced cooling, edge, a lot more detail. So I encourage you, if you have a team of engineers or you have a team of business development people, please check out the Global Summit schedule. Pick and choose those sessions which may be of the most valuable to you. And lastly, for the deck, you can always find us across the social platforms as well as on our main website. One final thought, always keep in mind that whatever market open source enters, it eventually dominates. And this was presented to me by my colleague who coined this phrase, and I really, I think it's true. In almost every aspect, you see how open source affects it. And I think in the medical field and in the healthcare field, you will quickly see the impact of open source communities over the next 12 to 24 months and how fast they work compared to proprietary legacy companies. So with that, I will turn it back over to Stuart. Thank you everyone for your time and attention. We hope that you found it a bit, some bit of value in this discussion.
That was really great. Thank you, Steve. Are we prepared for a few questions now? We have a few coming in from our audience. So if you're ready, Steve, I'll just fire away some questions. Sure. And then we can wrap this up. Okay, so great. We had one question right at the start. They're enjoying the session. Great to hear. Thank you, guys. So have your plans changed at OCP since the outbreak of COVID-19?
Have our plans changed? Is that the question?
Correct, yes.
Well, the plans on the contribution, as DJ had mentioned, he's outlined the direction of the IC. Those plans have not changed. We're seeing right now from the ODMs on the supply side, things are back up to normal here on the supply of OCP hardware coming out of North Asia, up to, I would say, 85 to 90%. Our efforts on driving awareness and education have certainly changed. And I know that the guys at CTC are implementing things quite differently. And some of these projects have either been pushed out or delayed, but still some companies are even looking at expanding infrastructure quickly to attack, say, certain opportunities, say in the education sector that needs infrastructure quite rapidly to handle some of the e-learning demands that have been posed in the market.
Well, that's really great to hear that things are on the up and getting back to normal. It's really encouraging to hear, especially in these times. Okay, so next question is regarding fintech. So they're curious, one of our listeners is curious to hear what types of firms are purchasing OCP servers? Because it seems like banks, exchanges, and trading firms are sticking to 19-inch.
So we're seeing on the fintech side, fintech specifically, as I'd mentioned in the previous, things like PayPal, not necessarily the traditional banks, they're a little bit slower to this type of model, but the fintechs are really adopting open networking quite aggressively. Now that's a lot of our switches are the traditional 19-inch form factor. So again, it's not necessarily the form factor, whether it be 19 or 20 or 21-inch. That's not necessarily the deciding factor of what makes something open compute. We have many 19-inch form factors out there. On the industry side, public sector is really adopting this aggressively as governments look for G-Cloud and those citizen services that involve a great deal of finance. But on the fintech, it's primarily we're seeing a lot of open networking as opposed to the core data center right now.
Okay, great. Thanks for that, Steve. And our next question, great to see so many questions. Thank you, everyone. When you reduce human resources while migrating to OCP, what is the recommendation to redeploy that human resource?
I had this discussion with somebody looking at open compute, and he said, look, I get 3 headcounts a year. So if I'm going to have those 3 headcounts, do I need to employ 1 additional data center operator? Or maybe I take those 2 extra headcounts and I move them to software development. Where we're seeing the move is toward less operations, more cloud-enabled software development. So as people start to implement hybrid cloud offerings, you're going to need those skill sets to handle the cloud-enabled apps. That's where you should be spending and reallocating your resources as opposed to the DC ops piece that's going to be greatly optimized by using an OCP infrastructure.
Great, and I think we have time for one more question. So, regarding power in data centers, has the market been headed for very high density?
Yeah, we see that. And if DJ, if you can help answer this question, you have a lot more access in what you're seeing across the Open Accelerator infrastructure project. DJ, can you help?
Yes.
Shed some
Yes.
on this?
Can you guys hear me?
Yes.
Okay. Yeah, I think that's a great question. And one of the things which I mentioned earlier was to standardize and have common platforms. Now, what that means is when you're deploying your systems at scale, you need to have some level of uniformity. You can have a few segments of, racks, for example, with few different type of power profile, but you cannot indiscriminately continue to have higher and higher power racks, because at the end of the day, you are limited by the power distribution system in the data center. And in most cases, these data centers are built in locations where space is not the issue. So in those cases, power density is not really a must-have feature for many of these devices, because you can spread them apart and still achieve your computational workloads over a bigger floor space. However, this is a very important question which comes up when you are looking at co-location or spaces which are a lot more confined. And in those cases, you could have a possibility of higher power density. But again, if you look at the small colos and small confined spaces, what you would see is cooling and airflow will become the challenge. So at the end of the day, the way you compromise this is by having a local points where you could have very high power, such as OCP accelerator modules, which can have very high power GPUs, which are running, terabits of teraops of operation. However, you cannot pack many of them in the same area, because at the end of the day, cooling will become an issue. So I think there is some point where you cannot go beyond in terms of indefinitely expanding power density. So I would say there will be some headroom for increasing the power, but you won't be able to do that indefinitely because cooling is a challenge and sometimes space is not a challenge. So hopefully that gives you some idea of the importance of this problem.
Thanks, TJ. You answered that a lot better than I would have, so thank you.
That's great. Thank you so much, guys. And thank you for everyone for delivering their questions. I'm sorry we couldn't get through them all, but I'm sure if you can contact OCP or ourselves at W Media, we'll be happy to get those questions answered for you. So thank you, guys. That was a really great session. It's really great to hear that OCP has helped businesses improve that efficiency and deployment speed. So it's really fantastic to hear. And I'd just like to say thank you to our speakers and a really big thank you to everyone joining us. We had over 200 join us today, which is absolutely fantastic. So thank you so much for joining us. I hope you can join us next time for the next Tech Talk with OCP, which will be focusing on open networking. That's scheduled for Thursday, the 21st of in 2020. So W Media will email you all the details for that, and as well as a recorded version of this webinar to share with your friends and colleagues. In the email, we'll also ask you for some feedback to determine the areas that you're most interested in for our third Tech Talk. So you actually get to determine what we talk about for the next one. So keep an eye out for that email and follow W Media on Facebook and LinkedIn, and you can also find myself on there too. If you want more, you can visit our website at w.media for the latest technology stories, market insights, and webinars. And W Media will actually be back on April 30th for our own Power Talk, where we'll talk about the state of the business right now and investment with the determination of COVID-19 and where that business is taking us and the future. So I hope to see you there. Thank you so much to everyone for joining. Take care and stay safe.